Well, welcome to our lesson on solving linear equations. This is lesson 7, and we're going to start out this lesson with some vocabulary. A couple of terms that you probably already understand and know and have worked with quite a bit, and the first of those is an equation. An equation is basically just a mathematical statement where it indicates that you have two expressions and they are equal. So the term that you need to be focused on here is the word equation comes from having an equal sign in the expression. So if there's an equal sign, it is an equation. If there's no equal sign, it's probably a mathematical expression. A linear equation is an equation that has this form where you have an x term and a constant term and it's equal to 0. Now, there are some restrictions on this. You can't have the coefficient or the a term being 0 because then this term would drop out and you wouldn't have a variable. So the variable has to be raised to the first power. So the power on x must be 1. It can't be anything other than 1 in order for it to be a linear equation. And you should know as well that a linear equation, when we graph it, it graphs as a straight line, and that's why we call it a linear equation. So this ax term is called the linear term. The other term, the b term, is called the constant. So a solution, a number is a solution to an equation if when you substitute it into the equation for the variable, you get a true statement. So that's how you define what a solution is. If it works in the equation when you substitute it and you get a true statement, then it's a solution. So those are our 3 vocabulary words for this section. Then we're going to jump into a couple of different properties that we will be using as we solve equations. So first of all, I have, oh, here we go again. This happens every time I do one of these videos lately. So the first thing is we are going to use these to solve equations, and the first one is the addition property. What the addition property says is that if we have two expressions being equal, we can add anything to both sides and it doesn't change the value of the equation. Similarly, the subtraction property says if we have some equation and we can subtract a number from both sides, and that doesn't change the equation as long as we're subtracting the same thing. The multiplication property says very similarly we can multiply both sides of an equation by a number and that won't change the value of the equation. Same with the division property. We can have two sides being equal if we divide by any number, as long as that number is not 0. Again, with multiplication, it can't be 0. We can multiply or divide, add or subtract any number, and it doesn't change the value of the equation. So those are properties that we use to solve equations. So here are some equations that we're going to solve. We're going to start very simple and we'll become more and more complex as we move forward. So the first one says solve this equation and we want to solve it for the variable. So when it says solve, we want to get x on one side, everything else on the other side of the equal sign. So the first step we're going to do then is we're going to add 9 to both sides. We're trying to isolate the variable, get it by itself. When we add 9 to both sides, the 9's here add to 0, so they drop out because they add to 0. So they're no longer on the left side. Then we get 3x is equal to negative 6. So our last step, x is being multiplied by 3, and we want to undo that multiplication. So we're going to use division. Division undoes multiplication, so we're going to divide both sides by 3. When we do that, we have 3 over 3, and that's equal to 1. Those drop out again. And then we just want to simplify the right-hand side. So negative 6 divided by 3 is negative 2. So we have solved and said x equals negative 2. Now, if you had to list the properties, I'm not sure in your homework assignment if it tells you to justify each step. This one right here would be the addition property. And you can abbreviate that if you want. So we ended up with this. Then we use the division property to solve for the next step. So if you have to list those, that's what they are. So here's one for you to try. It says solve, and you have variables on both sides this time. You probably know how to do this, but I'll go ahead and run through it quick with you as well. I would get my variables together first. So move your variables to the same side. We can do that by adding the opposite. The opposite of positive 2b is negative 2b. And so when we do that, we get 7 on the left-hand side. Okay, that just comes down. It's still there. These two add to 0, so we don't have to write it. 4b minus 2b is positive 2b, and the negative 9 is there. Our next step is going to be to add 9 to both sides. Okay, when we add 9 to both sides, the 9's add to 0, a negative 9 and a positive 9. And then the 2b is going to come down on the right-hand side, so we would have 2b equals 16. And then we need to use our division property. 16 divided by 2 and 2b divided by 2. The 2's drop out here. 2 divided by 2 is 1, so we have b is equal to 8. All right, so the next one, a little reminder for us. It says, remember to simplify each side before we use the properties of equality. What that means is we need to use our distributive property and combine like terms before we actually use any of those 4 properties. So my distributive property says to multiply the numbers through the parentheses, so 4 times w and 4 times 6, so I get 4w plus 24, and then I have a plus 2w, here's my equal sign, and then we're going to distribute the 7 through the parentheses, and we get 7w plus 21. So now that I've got everything expanded, here's my equal sign. I need to combine like terms. Well, the 2w and the 4w are considered like terms, so we need to combine those first. So I get 6w plus 24 equals 7w plus 21. Now it looks like what we had on the last slide. We need to get the terms that are alike together. So I need to get my 6w and my 7w together. And then I also need to get the constant terms together, the 21 and the 24. So that's where we're headed. So first I'm going to subtract 6w from both sides. When I do that, my 6w's drop out. They add to 0. Okay, my 24 comes down, and the 21 also comes down. And then I combine my 7w minus 6w, and I get 24 equals a single w plus 21. And I have one more step. I need to get rid of or get the constant terms together, so I'll subtract 21 from both sides. So once again, positive 21 and negative 21 adds to 0. So bring down the w, and I have w equals 3. Now here's one with fractions. I know some of you struggle a little bit when you see some fractions. So if we were to get a common denominator here, that would help us out. But I think a simpler thing is to find the common denominator, but then just multiply the entire equation by that denominator, and all of your fractions will drop out. So my least common denominator is 4. So if I go ahead and multiply this entire equation, I just rewrote it, and I'm going to multiply by 4. When I do that, 1/4 of 4 is just 1. So I get 1x. 4 times a half, or half of 4, is 2. 4 times a negative 3/4 is negative 3. So I have a minus 3x, and then 4 times a negative 4 is minus 16. So you can see now we don't have any fractions. So find your least common denominator and multiply everything by that number, and then they drop out, which makes life a lot easier. So now we need to get our like terms together. So what terms are alike? Well, we have our x terms. So let's work on getting our x terms together. Excuse me. So I'm going to add 3x to both sides. When I do that, my 3x's drop out on the right-hand side. They add to 0. And I end up with 4x plus 2 equals negative 16. Now I need to get my constant terms together, so I'll subtract 2 from both sides. And when I do that, I get 4x equal to negative 18. The plus 2 and the minus 2 add to 0. And last step is to go ahead and divide both sides by 4, since x is being multiplied by 4. And so I'll end up with 4x over 4 equals negative 18 over 4. Again, the 4's will cancel because anything over itself is 1. And so I end up with x being negative 9 over 2. That's the end of this video. We'll see you in class.